Good morning, all. This is Mr. Babcock, and we're going to start right on time. If you would do me a small favor, right in the middle on the bottom is chat. And if you click on that and type your name in and hit enter, it will help Mrs. Jacket with attendance. So right now, everybody, you'll see my name here in a second. Do that right there. Thank you, Eve. Thank you. Everybody, please do that. So if there's any questions on attendance, we can go back and look at the recording and see if we need to. So please do that. I'm going to get right into the lesson. Most days it will go something like this. I'll say good morning if there's any details or anything. For example, I hope all of you have already taken the pre-test. If you haven't, you need to get that in today. It should have already been taken. But most days I'll show you the objectives, what we're looking at, work some examples, and then look at the sheet that's called classwork. Usually on classwork, I'll work at least half, and sometimes all of it if we have time. And then the homework, which is very similar to that, different problems, but similar objectives. You have a week to the next Wednesday to work on it. Are there any questions before we get started?
Sir, you only have 3 on. You might want to wait just a couple of minutes.
Oh, so Mrs. Jacket, are you saying I have time for a pun?
No,
Class,
I did not say that.
That's what you're intending. Class, what do sea monsters eat? Anybody? Sea monsters. Time's up. They eat fish and chips. Right now, Mrs. Jacket is rolling on the floor. She is laughing so hard. Are you okay, Mrs. Jacket? Veronica, please go on the bottom of chat and type your name in if you haven't already. It's clear on the bottom, right in the middle. It'll say chat, has a little voice box. You click on that and type your name.
And second, Elizabeth, please go ahead and write. Oh, sorry, Liz, you just did.
Veronica. Devin, Veronica. There we go. Thank you. Fish and chips, Beth. See, fish and chips, fish and chips. That's a good one, wasn't it? Did you leave the meeting, Beth? Not talking to me again. That's okay. They'll just keep coming until someone laughs, Beth. You know me.
I'm here. I'm trying to help 2 students at one time, sir.
Well, it's 3 minutes after. I'm going to go ahead and get started. I'll try to remind everybody at the end. I'm going to share my screen. I'm going to go to the smart board. Okay, I didn't say it earlier, but this is, I hope everyone that signed in is level 2, and this is week 1. The overall objective for today is geometry with the coordinate system. Now the coordinate system, you ought to be familiar with it. There's 3 quadrants. In other words, if I plotted a point like this, that would be 1, 1, x and y axis. So what about geometry with the coordinate system? You start geometry back in grade school with circles and triangles and lines, but on the coordinate system, it seems to be a little different. So that's what we're going to do today. All right, under that geometry, here are the individual things we're going to look at. Lines with slope and intercept. I hope at least some of what we do each day is just a review for you. You've already been exposed, but then maybe some of it's new as well. So you've got to be patient with yourself. We're going to look at circles, and they'll be asking what's the center of the circle, what's the radius of the circle, and what's the area, which I'm sure you started back in junior high and middle school, but now we're doing it with coordinates. Right triangles, what's the area, and spatial right triangles. We'll look at some of those that you might see in any math course or on the ACT or any college course. And finally, distance between points, all those with coordinates, how far it is from 2 different points. Well, let's get right into some examples. Lines. This first line the blue line, it says y equals 3x plus 2. For several reasons, that would be my choice. In other words, if I had to see a line, that's the format I would have it in. It's called slope-intercept. What you see is what you get. In other words, the intercept, the y-intercept, I see at 2. It would start at 2 on the coordinate system, and the slope is 3 over 1. I'd go up 3, 1, 2, 3, and over 1, and that line looks like this. So if they ask me for what is the slope and intercept, I would say, well, the slope is 3, or 3 over 1, and the y-intercept, which we call b, is 2, or 0, 2. And that one's pretty easy because it's y equals. Also, if I wanted to, on y equals, I could use the calculator. You have a y equals key. So this is very familiar. I hope you've already seen that and say, oh yeah, slope intercept, what you see is what you get. I get that. The next one is in standard form, this black one. And it's a bit different. It's not a y equals. You could do it several different ways. There are some formulas, but my advice to you is to make it y equals. In other words, the first thing I would do is subtract 2x from the other side. I'd have 3y equals or minus 2x plus 6. All I did was subtract 2x over to this side. And then I would divide everything by 3. I would divide by 3. I would divide by 3. And I would divide by 3. So if I was asked for the slope and intercept here, I know the slope is negative 2/3, and I know the intercept is at 2, or 0, 2. So it starts at 2 and goes down 2 and over 3. And all negative slopes go up from right to left, where positive slopes, like this green one, goes up from right to left, from left to right, excuse me. But all positive slopes would go up from left to right. Let's look at the next one, next example. What is the slope and intercept? On this one, on the green one, is it y equals? Oh, well, I'm finished with the problem. Slope equals 1/2. The number with the x, what you see is what you get, and it starts at 0, -3. So if I wanted to graph that, I would go to 1, 2, 3, -3, and go up 1 and over 2, up 1 and over 2, up 1 and over 2. Notice the smaller the slope, this one was a fraction, the flatter the line is. In other words, if I had a slope of 8, wow, that would be a steep line. But if I had a slope of 1/8, that would be a very flat line. Even though both of them are positive slopes, it's a big difference on what the numbers are. The bigger the slope, the larger the number, positive or negative, the steeper the line. The smaller the number, the flatter the line. If I had a slope of 1, it would look like this. That's the line y equals x. It goes through 0, 0, up 1 over 1, up 1 over 1. If I had y equals, the flattest line I could have is y equals 4. That's a horizontal line, y equals 4. And that has a slope of 0. Or on the other case, that's a single variable. If I had x equals 4, that has no slope. It's so steep, it has no slope at all. So horizontal line, y equals, vertical line, x equals. The last example on this, on lines on slope and intercept, is this one right here. And there's no number, so I put a +0. So I know on the answer on this one is the slope is a -2, or 2 over 1. And the intercept, b, is at 0, 0. And the line would look like this, 0, 0, and -2 slope, down 2 and over 1, down 2 and over 1. And it's negative, so it goes up from right to left. So So there's some examples. I'm betting that most of you have already seen this and know that, and that's just a quick review, I hope. But we're going to work some more examples over here in just a second. Next category. Circles on the coordinate system. Lines, you have a y and an x. On circles, you'll have a y squared and an x squared. Huge difference between the two. So the characteristics that identify them should be pretty easy. I have a single x and a single y. But on circles, I have an x squared and y squared. Let's look at some examples of circles. There's several different ways to look at them. I look at completed squares. In other words, x squared, right here, x squared is completed square. I could write it as x plus 0 squared, if I want a number. Y squared is a perfect square. So I could write it as y plus 0 squared equals 9. So that circle right there, then we'll be asked several questions. One is, what is the center? Well, the center are the opposites of these numbers. Well, there is no opposite of 0, so the center of this one is at 0, 0. And on the coordinate system, I just put 0, 0 like I have here. Then it wants to know the radius. Well, the radius is this, whatever number squared is this. Well, 9 is 3 squared, so the radius is 3. So if I want to graph this circle, I'd say, well, it's at 0, 0, and I'll go 1, 2, 3, right, 1, 2, 3, left, 1, 2, 3, up, 1, 2, 3, down. I'd go at 45 degrees 3, all the way around, and eventually I get a pretty good graph of what a circle is. So there's a big difference between circles, even though you've had circles before. There's how it looks on a coordinate system. It is, if you say, well, that kind of looks familiar, it sure is. It's nothing more than the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared equals a hypotenuse squared. Well, on a circle, it's the x squared plus the y squared in completed square form equals the radius squared. So it's nothing more than the Pythagorean theorem. We're going to use that several times today. Well, there's how the first circle looks. Center was at 0, 0 and had a radius of 3. Let's look at the next example of circles on the coordinate system. This one is a completed square. Oh, and that one's a completed square for us as well. So the center of this one is at, I said the opposite. I need a 0 here, so it's -2. And over here it would be a +3. Notice I changed the signs on both of those. The radius, what number squared is 4? It's 2. Now, if it wasn't these nice completed squares, that's the next question up. That's another lesson altogether we'd have to study. How do I make it completed squares? Right now, they're all in this form right here. To graph this, I'd go to -2, 1, 2, 1, 2, 3 on the coordinate system. Right 2, left 2, up 2. And that's a pretty good freehand of what that circle looks like. Let's do one more example. One more example. If you're comparing and contrasting, for example, on a line, I want the y-intercept. So on this one, what you see is what you get, and I want the slope. Up 2 and over 1, up 2 and over 1. And it's similar to a circle. In other words, a line, I need slope, I need intercept. Oh, I get that. Well, on a circle, I need the center. This would be 6. There's no number here, so I guess that's y plus 0 and the radius is, what number squared is 16? It's 4. So comparing it to a circle, it's kind of the same, slope and intercept, but on a circle, instead of the intercept, I want the center and the radius. So if I graph this circle, I'd go to 6, 4, 1, 2, 3, 4, 5, 6. And the radius is 4. 4, 4. And freehand, that's a pretty good look of a circle. So lines and circles, they kind of compare. The difference is circles have two balanced square terms. A line just has an x and a y. On a line, we look for the slope and we look for the intercept. On a circle, we look for the center and we look for the radius. And we're going to do some more examples here in a little bit. Next topic on the coordinate system. Right triangles and areas. It says the sides of the right triangle are 20, 21, and 29. What is the area? Now, before I go any further, is that really a right triangle? How would you tell? What's the same theorem we used a while ago, the Pythagorean theorem? Before I go on and say what the area of this triangle is, I'm going to make sure it's just like they said, that it's a right triangle. So I'm going to say 20 squared plus 21 squared. Does that equal 29 squared? I'm going to do that arithmetic. It says it is. It says it's a right triangle. I'm going to make sure. Let's see. 20 squared plus 21 squared. That equals 841. And they said 29 was the other one. Well, sure enough, look at that. Right there. It is a right triangle just like they said. So I always sometimes like to check out and make sure what they're saying is true. Okay, it says, what is the area? And on the ACT and other tests, the MAP test and other things, there's two types of equations. One is they'll give you the equation, and that's kind of a technical reading, technical writing. The other type of equation is like this. They expect you to know. In other words, they're a lower level equation. So they would expect you to know that the area of a triangle equals 1/2 base times height. In other words, we've used that enough since grade school, we kind of know what the equation is. Well, I've got to take this equation now in green and put these numbers in. Well, I'm kind of a visual learner, so I'm going to draw a picture. This is 20. This is a little longer, 21. And the hypotenuse, that long side, which we've already looked, it's true, is 29. And since it's a right triangle, I know that 1/2 of 20 times 21, that's 1/2 base times height, should equal the area. Half of 20 is 10. 10 times 21 is 210 units squared. So the answer was 210. I hope that makes sense. So area of triangles, especially area of right triangles, we could do. What if they ask you for perimeter? What's the perimeter? You remember that? I hope you do. That's just the area around, and I would add all those up. 20, 21, and 29. That'd be 29, 30, 40, 50, 60, 70. 70 units is the perimeter. So we ought to know both of those equations. So those are types that they'd say, well, I'm not going to give you the equation. We kind of expect you to know. And the key to it right here is what was the area, and it was a right triangle. So I knew that had to be the base and height, or you could say this is the base and this is the height, and the long side was the hypotenuse. Well, let's look at some special right triangles. There's two that you really ought to know. Today we're just doing one of them. And it's a 30, 60, 90 degree triangle. We know that if we add up all the angles in any triangle, 90 plus 60 plus 30 is always 180 degrees. And 30, 60, 90 is a special one. On that last one, on the Pythagorean theorem, I said that 20 squared plus 21 squared equals 29 squared, and that's how I looked at it. However, on spatial triangles, and this is the first one that we talked about, if you don't know it, it's time you learn. You can't use the Pythagorean theorem. They'll say something like this: the hypotenuse is 10. Find the other sides. Find the area. Oh, wait a minute, Mr. B. They've only given us one side. Well, on a 30, 60, 90, okay, on a 30, 60, 90, you're supposed to know the ratios. It's kind of like the area of the triangle. If you haven't seen it before, let's learn it. The first one is 2 to 1. And the way I remembered it in high school, that's always 2 to 1. So this short side is 5. It's always 2 to 1 ratio. The other side is the short side, 5, times the square root of 3. Now, the reason that turns out that way, it's because of the Pythagorean theorem. You say, what do you mean? I don't see, Mr. B. What's the Pythagorean theorem? Well, if I'm given one side on a 30, 60, 90, the other ratios always come out this way. So if I was using the Pythagorean theorem, I would say 5 squared plus 5 square root of 3 squared equals. And I do that arithmetic. 5 times 5 is 25. 5 times 5 is 25. 3 times 3 is 9. Square root of 9 is 3. So I have 25 plus 25 times 3. 3 times 25 is 75 plus 25. And that is 100. What's 10 squared? Oh, that really works, Mr. B. Remember, it's 2 to 1, the short side times the square root of 3. Now, when you get a different spatial right triangle, for example, 45, 45, 90 is another one they would expect you know we may do later on in the course. When you do that one, it's a square root of 2 that you use. Let's do another one here. Let's say this was 6. What's this side? Double it. That's right, 12. What's this side? 12 square root of 3. Always turns out that way. Let's do another one. I want you to do this one. If I said this is 7 square root of 3, do the other sides. Do this one and do the hypotenuse up here. Go. You have 10 seconds. What would those other two sides be? I hope you have it. This would be a 7. This would be 14. You see the 2 to 1 ratio? Let's make it a little harder. What if this side was, what if this side was 9? What would this side be? 4.5. You get fractions sometimes. What would this side down here be? 4.5 square root of 3. And on any of those, any of the different colors that you take on a 30, 60, 90, you could do that ratio. It always works out with the square root of 3. This is 2, this is 1, and then you take the 1 square root of 3. And the reason is the Pythagorean theorem. Let's see if you can do one from start to finish that we might see. This side is 3. This side is 3. Find the area. Find the area. What's the area of that right triangle? If that side's 3, it's a 30, 60, 90 degree triangle. Give it your best shot. Okay, let's see if you have it. This side is 6, but I don't really need it. It's the hypotenuse. This other side here is 3 square root of 3. Well, here's the base and here's the height, so I'd use the same equation. It's 1/2 3 square root of 3 times 3. 3 times 3 is 9. Half of 9 is 4.5. times the square root of 3. I might want to pick up a calculator and estimate it. That's about 7.8, somewhere in there. It's not quite 8 square units, and that would be my answer. This is the exact answer, 4.5 square root of 3. This is the approximate answer. 30, 60, 90 degree triangle. We'll use that here in just a second. Right triangles. It's not the only one, but it's usually the first one that you look at. Okay, let's look at the area of a circle. And we've already talked about circles today. Right now, everybody see if you can do this one. What is the center? That's a completed square. Both of these are completed squares. And what's the radius? Fill in those two blanks. Let's take about 10 or 15 seconds and see if you can do that. What is the center? And what is the radius? It's in the correct form. What do you think? Well, I hope you said the center was, there's no number here, so it must be a plus 0. Take the opposite of this is 3. And the radius, what number squared is 25? 5. So there's the center and the radius. Okay? But it said, what is the area? Well, that's another one of those type 1 equations. They expect us to know the area of the circle. Area of a circle is pi times radius squared. So that equals pi times 5 squared, which is 25 times pi. And I would estimate, and just make sure it looks about right, that's about 78.5. And I might want to look at the coordinate system to make sure that that was about correct, but about 78, 79 units. Or if you wanted to, the exact answer here is 25 pi. There is the approximate answer. So that equation we're going to use today, the area of a circle is pi times radius squared. Perimeter, if they ask us for it, is 2 times radius times pi. And most of the time on the math and ACT test, they expect you to know both of those equations. So you might write them down. I'm sure you've seen them before, but if it's been a while, you might want to write them down. Okay, area of a circle and perimeter. The last thing we're going to look at is the distance between 2 points. Again, it's the Pythagorean theorem. Distance equals the square root of x squared plus y squared. Well, if you take that equation and take the square of both sides, you get d squared equals x squared plus y squared. And it's the same thing as the Pythagorean theorem. A squared plus b squared equals c squared. It's right from the Pythagorean theorem. Another way to write it, instead of x squared, y squared, you could say x minus x squared, y minus y squared. Let's see if we can do one here. Let's use the formula. I'm going to say that the distance equals the square root x minus x. Right there, that would be 3 minus a squared. What would that be? Well, that's 4. The distance from 3 to -1 back to -1 is 4 squared plus y minus y. 7 minus 4 squared. How far from 7 to 4? Well, that's 3 squared. 16 plus 9 is 25. Square root of 25 is 5. Now, the reason I like geometry with the coordinate system, I like to look at it. So I'm going to look at the coordinate system here. There's my y-axis, my x-axis. I'm going to look at 3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. There's 3, 7. And the other point was negative 1, 4. Negative 1, 1, 2, 3, 4. There's the length that we had there. Now, I think the answer is 5. Let's see how that looks. 1, 2, 3, 4. Oh my gosh, it looks like it looks just like it. And so a lot of times on the coordinate system, whatever your answer turns out to be, it should look right when we do it on the coordinate system. It's a way to check it. And when you can tie both of them together, the equations and the coordinate system in geometry, a lot of it is very useful in all kinds of occupations. Okay, next thing I want to do is go to the classwork. We're going to work together. So now let's see what the homework might look like. So on the classwork, on that sheet that we do together, and usually we'll do a majority, if not all of them, in class together. That's what the homework will look like as well. So you ought to be looking now at the classwork. Okay, so this is week 1 classwork, and the homework will look very similar. Number 1, what is the slope and y-intercept of this line? Oh, great. Look at that. It's y equals. What you see is what you get. The slope is 5. No. Slope is 5 and the intercept is -2. The answer is B. The answer is B.
Sir, I'm going to stop you a minute. Everybody want to write this stuff down.
Sometimes it was y equals. Remember on lines y equals, what you see is what you get. What you see is what you get. They've given you the answer. And on this one, I saw the slope was 5 and the intercept was -2. And right now, when I see that, it's hard for me not to be doing this. It hits at -2 and the slope is 5 over 1. It's a very steep line and it looks like this. So that's what that information does for us. Let's go to the second one, number 2. Take about 10 or 15 seconds, see if you can answer that. What is the center and radius of this circle? Oh, it's a circle. There's an x squared and a y squared. See if you can get the answer on that. Let's take about 10 or 15 seconds. Give it your best shot. Well, do you have an answer? The radius is 5. 5, 5, 5, 5. Dang it, they're all 5. That didn't help me at all. The center, always change the sign, would be -6. These two are out because they're positive 6s, and +8. The answer is C. The center is at -6. Change the sign. I need the 0 here. And +8, and the radius is 5. So on number 2, the answer is C. Number 3, these sides form a right triangle. Then what is the area of this triangle? Well, I'm a visual learner, so I'm going to draw it. There's 12. There's 5. There's the hypotenuse, 13. Well, apparently they didn't give me the equation, so they expect me to have it. So the area, I know, but any triangle is 1/2 base times height. So it's 1/2 times 12 times 5. Half of 12 is 6. 6 times 5 is 30. Answer C. Answer C. Let's go to number 4. The hypotenuse, there's that special one with 30, 60, 90. right triangle of the hypotenuse of this 30, 60, 90 triangle is 16. The hypotenuse. Oh, what is the approximate area? Okay, well, let's see if we can do this one. I'm going to draw it here. Again, I'm a visual learner. 30 degrees, 60 degrees, right triangle, and they told me the hypotenuse is 16. This side's 8, it's 2 to 1, 2 to 1. The way I keep it straight, well, look at 30, 60, 30, 60, that one opposite is a small one. This one's 8, square root of 3. The spatial ones always involve a square root, and this one's 30, 60, 90, all those threes has to be a square root of 3. So the approximate area, 1/2 base times the height. Half of 8 is 4. 4 times 8 is 32. And at that point, I'd probably get out a calculator or estimate the square root of 3. It's around 1.71, or just use your calculator. Be sure to close your brackets when you do that. And I think it's around 55 square inches, approximately. Answer C. This is the exact answer. So if I take 32 times the square root of 3, which is 1.71, approximately, it's irrational, is around 55 square inches. Okay? Number 5. What is the approximate area of this circle? I tell you what, it didn't ask for it, but right now, take 5 seconds. Tell me the center, tell me the radius. 5 seconds, go. It's in correct form. Time's up. Did you get it? The center is at -7, 4. Notice you change the signs, the radius is 10. So I want the area. Area equals pi times radius squared. 100 pi, 3.14 times 100 is that, it is B. 314. Probably ought to look at all the answers, but B is the correct one. That is the approximate area. By the way, so far all these numbers have been real nice, perfect squares, but you could have one like this. X squared plus Y squared equals 10. And someone asked me what the center is. Well, it's got to be 0, 0. What's the radius? Well, I don't know. It's the square root of 10, 3.1, I don't know. Whatever the square root of 10 is. So don't get the idea that the radius always comes out nice. They don't sometimes. Answer to this one was B.
Sir, can you go back up to number 3?
What is the slope and y-intercept of this line? Doggone it. It's not y equals. So that's what I would immediately do. I would change it to y equals. First, I would subtract 5 to the other side. So I have 4y equals minus 5x plus 12. Subtracted 5 from both sides. Next, I would divide by 4. I would divide by 4. And I would divide by 4. So now it's y equals, and what you see is what you get. Slope is a minus 5/4. That's the only one I can mark out. All the others are a minus 5/4. The intercept is 3. That one's 4. The answer is D. Slope is 5/4, and the intercept is 3 on the y-axis. And the last one on the classwork for today. What is the distance between these 2 points? Well, distance equals x minus x squared plus y minus y squared. And then you take the square root of that. Let's see if we can do it. From 4 to -4, how far is that? Well, that's 8. From 8 to 2, that's 6. 8 squared is 64. 6 squared is 36. That is 100. And the square root of 100 is 10. Now I'm going to see what that looks like on the coordinate system. 4, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. -4, 2. 1, 2, 3, 4, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks good. The distance between the 2 points here is 10. I have a few minutes left. If you have a question, unmute yourself and ask away. Go ahead. Who's first? We still have a few minutes for questions on any of those on the classwork you want to see or had a question about. Questions, please? Any questions?
I think we have several questions, guys.
Well, I'm going
Ask
to
them.
stop sharing the screen. Before we leave here, 2 things. I would use Carissa in the study session, and she can call or email me whenever. Also, if you have questions and Carissa's not available, go back and look at the recording. These recordings will be posted. And so when you're looking at one and have a question you didn't want to ask, I would look at the time on it, how many minutes have gone by since 10 o'clock, and just write it down. That way you can find where you want in the recording fairly quickly. One last time, are there any questions on the topics that we had for today? A couple quick questions on administrative. How do we take attendance? Well, if you haven't already, on chat, I'm going to do it again right now. Chat. Just hit chat and I'm going to type my name and hit enter, and this comes in, and that way we can see it, and Miss Jacket can see it easily as well. So if you haven't done that yet, please do that before we sign off here in the next minute or so. Each week you have 2 things due. One is the classwork, and usually just like today we did them all, that's due. And then you'll have a homework sheet that has problems that are the same objectives, just different numerical values. Was Daniel going to come back in and show them? Was Beth going to show them again, or she already done that on turning in homework?
I don't think we have yet.
And no one's talking to me. Are y'all mad at me? My wife, she loves me, but sometimes she gets mad and doesn't talk to me. Usually it's nearly always my fault. So I don't know. What have I done today? Beth, is everything okay? Miss Jacket? Carissa,
Yeah,
is it okay? Boss,
I
is it
can
okay?
talk to him about turning.
We're going to stop recording. Do you want them to hang around like you did on the other section, or are we good?
Yes, we're going to show them that Chrome, I forgot what the word is, the thing to add on Chrome. So everyone else stick around.
I can't hear you, but I'm assuming you can hear me.
Oh,
Did you unmute yourself?
Yeah, I can hear you.
Oh, okay. All right, so students, hang around for a second.
Well, I'll leave and stop the recording, and I'll see you next Thursday, and we'll look at some new topics. Thank you all very much, and good luck with your homework.
Thank you.
Can you guys hear me?
Yeah.
Okay. He must have had something messed up with his speaker. I don't think he could hear us. Okay, walk into another classroom real quick, just so I don't interrupt those that I'm working with here. Guys, in your Chrome web store, there is an extension called Cami. It's an option on how to turn your homework in. A lot of you maybe are already used to turning it in by taking a picture. Okay, so what he did in class today is called classwork. By you turning in that you wrote everything down that he did, you get 10 points. And so it's just, you're basically kind of like taking your notes and doing example problems. So you either want to take a picture with your phone or do print screen, some kind of option of that you actually wrote down. You have to show your work and then show what the answer is. So you can't just type in A, B, C, D and get credit. You have to show that you wrote stuff down. But there is an extension that is called Cami that you can actually annotate on the screen. If you have access to any kind of tablet with a pen or pencil that you can write on, it's really easy and it goes a little bit quicker. So I'm going to share my screen with you and I'll show you how to go find that if you want to watch. Right up here in the top left corner of your Chrome, you see the boxes that says apps. You'll want to click on that and go to web store. And then under web store, you just type in K-A-M-I. And there's this thing called Cami, and they made it free when all of this COVID happened. So it made it free to students. So you just click on it. I've already downloaded it, but yours would say, you know, install or something like that here. So I'm going to copy this and put it in the chat as well. So you could just go straight there. Oh, John already did that for me. Thank you. So once you load it, the cool thing about it is if you're in Google Classroom, you can open up what he did today, which is classwork. And you can click on it and open that document up. So this is what he did in class today. The first time up here, there'll be a drop down arrow and you'll have to pick open with Cami, but after you do it once, it'll be automatically there. And so when I open with Cami, it goes into this program and it'll convert it over. And it takes just a minute to process it and convert it. So there's that same worksheet. And then over here, you can actually create a text box. The equation is blocked for the free version. You would have to purchase to be able to do, to do that. But then right down here is a drawing version. So I could pick, you know, a color, and then I could come up here and show my work. I'm on a computer with a mouse, so I'm not doing very good with this. But if you had access to a touch screen where you could actually write on it, you could show your work right on the paper and then pick your answer. And then right up here in the top corner, you could save it and then upload it to Google Classroom. So that's just an option to help you guys submit your classwork. But again, a lot of you might just want to take a picture of your piece of notebook paper and upload it that way.